Hello everyone, my name is Devendra Srivastava from third year electronics engineering student in Dr. Ambedkar Institute of Technology, Kanpur, Uttar Pradesh. We are here to project on microwave oven simulation, which we have done in this internship provided by Emertxe Information Technologies, Bangalore, and also must be internship provided by Emertxe Information Technologies. We will let's see the goals of our internship to learn about C languages and embed C programming, to learn about the microprocessor and microcontroller, to learn and implement the project of microwave oven simulation on PIC microcontroller. Let's see the table of contents, introduction. Let's see the cooking modes, tools which are required to be installed, topics which are learned during the internship. What are embedded systems? Microcontroller and microprocessors comparative analysis. What is PIXM, XCF compiler, and MPLAB XIDE? What are CLCD tactile switches, matrix keypad? What are interrupts, ISR timers, and conclusion? And in the end of this video, we will also see the live project demonstration of our internship project. Now, the first question, what is microwave oven? Microwave oven is used to heat the food and for the cooking purpose using microwaves, which is of the forms of electromagnetic waves. There are several modes in microwave ovens. Here we are going to implement four cooking modes: micro mode, grill mode, convection mode. Let us explore the each mode. First of all, micro mode. In this mode, we have to set the power level of cooking in which heating is done by microwave, and we have to implement such a system that will set cooking time in micro mode, and after completion of given time it have to give an alert. Maximum power used in this mode is 900 volt. Then the second mode is grill mode. In this mode, we have to set up the timer for cooking by presenting keys. We have several keys on board, so have to set up different functions to different keys. This mode is used to cook meat and bread. Now the third mode is convection mode. Convection mode enables you to cook food in the same way as in traditional oven. We have to set the temperature as required in this given range. It takes 180 seconds to preheat the oven. We have to keep the door closed. If the door is open, we have to give an alert and turn on the buzzer and turn off the fan. Tactile switches. A tactile switch is a type of momentary contact that provides a physical response to the site when activated. This response is usually a kick or a slight bump confirming that a switch has been pressed. Now, the matrix keypad. The matrix keypad is a type of an input device that uses a grid of interconnected buttons to allow for a large number of key inputs with a minimal number of pins. Each key is located at the intersection of a row and a column. Here we can see the matrix keypad where there are a set of wires and these are jumper pins, and these are keys which correspond to different type of functions. Now, what are interrupts? Now, interrupts are special occurrences or instances in microcontrollers, which are crucial mechanisms that allow the microcontroller to respond to events in a timely and efficient manner. They are like a pause button for the main program, enabling the microcontroller to handle urgent tasks or external signals without disrupting the overall program flow. Now, in types of interrupts, there are two types of interrupts, which are hardware interrupts and there are software interrupts. Now, maskable interrupts and spurious interrupts. The maskable interrupts are the type of interrupts which can be enabled or disabled. Now, ISR. So, there might be situations when there are different type of interrupts. So, to deal with, there is an interrupt service routine which also handles the various types of interrupts. Is also called as interrupt handler. It is a special block of code within which a program is designed to be executed when a specific interrupt occurs. Interrupts are signals to the processor that an event has occurred or an immediate action is required. Timers are the most crucial component of any part of embedded systems. Dimers are essential components within microcontroller that provide precise timekeeping and control capabilities. They function as specialized counters that increment or decrement at a rate determined by a clock source, counting clock cycles, generating time delays, periodic events, interrupts, pulse width modulation, input capture, clock source, internal or external, prescaler, counter resolution. Counter resolution 18, 16, and 32-bit. Start mode. After selecting the start mode by presenting the key in the matter keypad, the book starts automatically. Now, what are some tools required for the development of our project? MPLAB X IDE, XC8 compiler, XM simulator, microcontroller PIC16F8778, port 16 cross LCD displays, tactile switches, matrix keypad, and two timers. Now, we see what are the differences between or what are embedded systems. So, embedded systems are specialized computers which are designed to perform specific tasks within a larger system. There are combination of hardware and software, often with real-time computing constraints. Embedded systems are found in variety of devices, ranging from appliances like microwave oven, washing machine, to into complex systems like airplane and medical equipment. There are four types of embedded systems. Firstly, standalone systems. Standalone systems are systems that can operate independently without relying on the other systems or networks. They have all the necessary components and resources to function on their own. Standalone systems are often used in situations where connectivity is a concern, limited or unreliable, or where security is a major concern. Examples of standalone systems include personal computers, embedded systems, and some industrial control systems. Second is real-time systems. Real-time systems are computing systems which are designed to react to events within strict time constraints. The correctness of the computer system depends not only on the logical result of the computation, but also on the time it was produced. These systems are crucial in applications where time is of the essence, such as in industrial control, aerospace, and medical devices. Real-time systems are categorized as hard if they are missing a deadline results in a system failure, and soft if occasional missed deadlines are tolerable. Network systems. Network system consists of multiple interconnected devices or components that communicate and exchange data with each other. These systems can range from local network connecting a few computers to large global network like the internet. Networks systems enable resource sharing, collaboration, and distributed computing, facilitating communication and access to information across geographical boundaries. They are essential for various applications, including communication, entertainment, business, and research. Mobile systems. Mobile systems are computing systems designed to be portable and capable of connecting to networks wirelessly. They encompass a wide range of devices, including smartphones, tablets, laptops, and wearables. Mobile systems are characterized by their small size, lightweight design, and ability to operate on battery power. They are designed to support mobility and enable users to access information and applications from anywhere with a network connection. Mobile systems have become an integral part of modern life, enabling communication, entertainment, productivity, and access to information on the go. Now, how we can choose the embedded systems of our own requirement? First, it should consume very low power. There are often times where embedded systems are to be operated upon battery or with low power. So, low power consumption is a key factor while designing an embedded system. Cost efficiency, since they are standalone features, so the cost efficiency should be high, as uh, we can't use general processors. They are standalone computers. Efficient use of processing power. They should be reliable. Efficient usage of memory, since they are resource constraints. Comparison: microprocessor and microcontroller. Microprocessor are General purpose CPUs requiring external components for memory and peripherals, while microcontroller integrate these elements onto a single chip for specific tasks. Microcontrollers, microprocessors are used in computers, whereas microcontrollers are common in embedded systems. There are two types of circuits: syncing circuit and sourcing circuits. Sensing circuit are also known as current sinking circuit or low side driver is a type of electronic circuit that controls the flow of current to a load by providing a path to the ground. It sinks current from load from higher potential to lower potential, effectively turning it on or off as a switch, like we saw in the application of tactile switches. Now, sourcing a source circuit, also known as a current sourcing circuit or a high side driver, provides current to a load. It acts as the source current, effectively turning the load on or off. The switching element, often a transistor, is connected between the power supply and load. During the course of internship, we first started with learning with C programming. We learned about what is programming, the basics of programming, such as variables, what are data types, what are operators. We built some basic programs, then we moved on to the higher version to the arrays and strings. Then we moved on to the most important concept while dealing with embedded programming, that is called pointers. After doing the lot of practice on C programming, we moved to studying microcontroller. We studied about microcontroller, the microcontroller which we are also using. The then we studied about various components which we will be using, such as CLCD displays, timer units, and timer units, CLCD displays, matrix keypads, such components which integrating them with our one window, we can create our standalone projects. Let us see how we integrated our code. We use embedded C programming as the language of programming in MPLAB XIDE version 6.20. Here is the code which we have written. It contains two types of files like header files, CLCD main, matrix repair, head timer files, and source files, CLCD ISR, interrupt service routine files, matrix C files. So here we can see that different types of files are put in one project, and all files are dealing with specific type of function, and they all are integrated with the help of main.c function. So this debugger will compile this code, and to run this code on our pixm lab, we will need to first click on this microwave oven project, left click, clean and build. Then it will be building the hex file or load hex file, which will be burned to the Pixem lab. So here we can see that build is successful. Total time took 6 seconds. Now this is the address where Pixem lab hex file will be loaded completely. Now this is showing that it is loaded. So now let's see the implementation part. So here, now with the help of load hex, we can write in this file. As we can see, if you press the reset button, that grid is coming, powering on microwave oven. So this is the basic user interface of our Pixem Lab PIC16F877A module. Now, as we studied in the microwave oven, there are four modes: micro mode, grill mode, convection mode, and start mode. Now, first, let us examine the micro mode. In micro mode, the power maximum used is 900 watt. Now, it is asking to set the time count. Now, let us set the time count by 40 seconds. If we want to clear, then we can press the start button. If we want to start, then we can press the enter button. Now, as we can see, the fan has started. It means the microwave oven has started functioning, and timer count is started decrementing. The temperature is showing 27.5 degrees Celsius, where we have four features: start, resume, by pause or stop. So if we want to start again or resume, we can do the press the keypad 4, press the key 4. If you want to pause it, we can press the key 5, just like we pressed the key 5, and now the counter has stopped. Now if we have again, it is working. Now if we can press 6, it will stop. So let's just wait till the time it runs over. 5, 4, 3, 2, 1, times up. So now here the message is showing cooking time up. So let's restart powering on microwave one. Now let us explore the grill mode. Now to explore the grill mode, we should press the key 2. If we press the key 2, here we will set 5 seconds. Let us see hash. So after 5 seconds, it is running. So cooking time is up. Let us see the third mode, convection mode. Here we can set the temperature as let's suppose 30, timer to hash preheat remaining. This is the preheating phase of 180 seconds. It is nothing but a 3 minute countdown. Now let's wait for 3 minutes. So let's just skip this timer phase. So we have explored the third mode also. Let us see the last mode, start. So as we press the start button, it will automatically set the timer at 30 seconds and it will continue. See, the fan is running. It means microwave oven is on. And here are some visitor integrated components. Now, after the 30 seconds, this mode will also on. So, this is the project we made during the course of our internship. I'm thankful to Emertxe Information Technologies for providing such a wonderful opportunity to build some such a great project. This project will highly make my resume useful and thank Information Technologies for providing this opportunity. Let's just wait. Yeah, we have explored all the four modes. Thank you for watching the video. Thank you.